Download this code from codegive.com, link in the description below. Comprehensive tutorial, Try-Catch Blocks and Currency Converter in Python. This tutorial covers two essential aspects of programming in Python. 1. Error handling with try-catch blocks. Learn how to gracefully handle potential errors in your code using try-except blocks, also known as try-catch in other languages. This prevents your program from crashing and allows you to provide informative messages or take corrective actions when exceptions occur. 2. Building a simple currency converter. Will apply our understanding of error handling while creating a basic currency converter program. This will demonstrate how to fetch exchange rates, validate user input, and perform the conversion. Let's dive in. Part 1. Error handling with try-except blocks. What are exceptions? Exceptions are events that disrupt the normal flow of a program's execution. They can occur for various reasons, such as invalid input, user provides text when a number is expected, file not found, trying to open a file that doesn't exist, zero division, attempting to divide by zero, network issues, failure to connect to a server, incorrect data types, trying to perform an operation on incompatible types. Without error handling, when an exception occurs, your program will usually crash and display a traceback, which can be confusing for users. The try-except block structure. The try-except block is the standard way to handle exceptions in Python. Here's the basic structure. Explanation. 1. Try block encloses the code that you suspect might raise an exception. The Python interpreter will monitor this code for any exceptions. 2. Except block, follow the try block. Each except block specifies the type of exception it intends to handle, exception type 1, exception type 2, etc. You can have multiple except blocks to handle different types of exceptions in different ways. As E1 this part is optional but highly recommended. It assigns the exception object itself, the instance of the exception that occurred, to a variable, example E1. This allows you to access information about the exception, such as the error message. 3. Else block this block is optional. It's executed only if the code in the try block executes successfully and no exceptions are raised. It's a good place to put code that should only run when things go as planned. 4. Finally block this block is also optional. It's guaranteed to execute no matter what, whether an exception occurred, was caught, or wasn't caught. The finally block is typically used for cleanup actions, such as closing files, releasing resources, or ensuring that certain operations are always performed. Example, handling value error. The value error exception is raised when a function receives an argument of the correct data type but an inappropriate value. For example, trying to convert a string that doesn't represent a number to an integer. Example, handling zero division error. Multiple except blocks. You can have multiple except blocks to handle different types of exceptions in different ways. This allows you to provide more specific error messages or perform different recovery actions depending on the type of error. The else block. The else block is executed only if no exception occurred in the try block. It allows you to separate the code that might raise an exception from the code that should only run when everything goes as planned. The finally block. The finally block is executed always, regardless of whether an exception occurred or not. It's used for cleanup tasks such as closing files, releasing resources, or ensuring that certain operations are always performed. Raising exceptions manually. You can also raise exceptions manually using the raise keyword. This is useful when you want to signal an error condition that your code has detected. Best practices for error handling. Be specific. Catch specific exception types rather than using a general except block. This helps you handle different errors appropriately and avoid masking unexpected exceptions. Log errors. Log errors to a file or database for debugging purposes. This is especially important in production environments. Provide informative messages. Display user-friendly error messages that help users understand what went wrong and how to fix it. Avoid overusing try-except. Don't use try-except blocks as a substitute for proper validation and input sanitization. Prevent errors from happening in the first place whenever possible. Re-raise exceptions. In some cases, you might want to catch an exception, perform some cleanup or logging, and then re-raise the exception so that it can be handled further up the call stack. Use raise, without any arguments, to re-raise the currently active exception. Part 2, Building a Simple Currency Converter. Now, let's apply our understanding of error handling to create a basic currency converter. This program will 1. Get the user's input for the amount to convert, the source currency, and the target currency. 2. Fetch the exchange rate from an external API, we'll use a simple example API. 3. Perform the conversion. 4. Display the result. 5. Handle potential errors gracefully, example invalid input, network issues, invalid currency codes. Code example, currency converter. Explanation 1. Import requests *. This library is used to make HTTP requests to fetch the exchange rate data. Make sure you have it installed, pip install requests. 2. API_key and exchange_rate_URL *. API_key. Some APIs require an API key to access their services. If the API you choose requires a key, replace your _API_key with your actual API key. Many free APIs have usage limits, so be mindful of that. *exchange_rate_URL, this defines the base URL for the exchange rate API. The placeholder will be replaced with the base currency. Important *, the specific URL and data format will depend on the API you choose. 3. Get _exchange_rate, from _currency, to _currency, *. This function fetches the exchange rate from the API. It uses a try-except block to handle potential network errors, requests.exceptions.request exception, invalid currency codes, key error, and other unexpected errors. Response.raise_for_status, this is a convenient way to check for HTTP errors, like 404 not found or 500 internal server error. If the response status code indicates an error, it will raise an HTTP error exception. Returns none if it fails to fetch the exchange rate. 4. Convert _currency, amount, from _currency, to _currency, *. This function performs the currency conversion. It calls get_exchange_rate, to get the exchange rate. It uses a try-except block to handle value error if the user enters an invalid amount, something that can't be converted to a number. It returns none if it fails to perform the conversion. 5. Main, *. This function handles the user interaction. It uses a while loop to allow the user to perform multiple conversions. It prompts the user for the amount, source currency, and target currency. It calls convert_currency, to perform the conversion. It displays the result. It handles any unexpected errors in the main loop using a try-except block. 6 if underscore underscore name underscore underscore equals underscore underscore main underscore underscore colon asterisk. This ensures that the main function is only called when the script is executed directly, not when it's imported as a module. How to run the code asterisk. 1. Install the requests library asterisk. 2. Choose an exchange rate API asterisk. The code above uses exchangeRateAPI.com. Carefully read the API's documentation regarding usage limits, attribution requirements, and data format. Some APIs require you to sign up for an account and obtain an API key. There are also other options for free exchange rate APIs that you could consider. 3. Replace the placeholder API underscore key with your actual API key if required by the API you chose. 4. Save the code as a .py file, example currency underscore converter.py. 5. Run the script from your terminal. Important considerations asterisk. Asterisk API limits asterisk. Be aware of the usage limits of the exchange rate API you choose. Free APIs often have rate limits, the number of requests you can make per minute or per day. If you exceed the rate limit, you'll get an error. Asterisk data accuracy asterisk. The accuracy of the exchange rates depends on the API you use. No API is perfectly accurate, so the results should be considered estimates. Asterisk error handling asterisk. The error handling in this example is basic. You might want to add more sophisticated error handling, such as logging errors to a file or providing more detailed error messages to the user. Asterisk input validation asterisk. Consider adding more robust input validation to ensure that the user enters valid currency codes and amounts. You could use regular expressions to validate the format of the currency codes. Asterisk user interface asterisk. This is a command line program. You could create a graphical user interface, GUI, to make it more user-friendly. Libraries like tkinter, pyqt, or Kivy can be used for creating GUIs in Python. This detailed tutorial provides a solid foundation for understanding error handling with try-except blocks and building a practical currency converter program. Remember to adapt the code to your specific needs and the requirements of the exchange rate API you choose. Good luck.